Why initial state to be final state? 4 number. What are the remainder? This is my final state. These are a non-final state. 5 number. I am taking the trick from that. Always try to put initial to final state because it is depend on modulus part or remainder. Clear it? Fine. I am already proved it. So how can we write this tension difference? I have also trick. Simple. 0, 1. What is my remainder? 0 and 1. I am only using 2 times. 3 cases. 0, 1, 2. 3 times. Again I am starting 0, 1, 2. So 0, 1. And here next 0. This is my initial state. This is my final state. Theta draw करिए 0 1 Q0 Q1 Q2 remainder कितने 0 1 2 but input symbol is 2 mind it input symbol is true because we are dealing with the binary number if you are using ternary number we are using 0 1 2 input symbol so here it is simple 0 1 2 0 1 2 ठीक ऐड करके लास्ट एंटर कंप्लीट ଏବେ स्टेट डायग्राम पकेबा नो इश्यू सिंपल वन एटा गेट फंडामेंटल्स तो हाउ टू इजीली सॉल्व विद इन 1 सेकंड इसको अब स्टेट डायग्राम क्यों लिखा नो इश्यू A, B, C, D you can write it. That's the naming, nothing else. Fine. 4 draw करिए. Diagram का सी. 4 draw करिए. 0, 1. Q0, Q1, Q2, Q3. This is my initial state. This is my final state. Simple. Remainder is 0, 1, 2, 3. 0, 1, 2, 3, 0, 1, 2, 3. Write down. Within 1 second you got the solution. Diagram draw करिए. System लिखिए. Start करिए. Okay. So I am just designed that diagram. So we are using concept as JFlop is your tools. Before you JFlop to be installation in your system, JDK or Java Eclipse will be installed. Otherwise JFlop cannot be. So better is that 7.1 version you have to use it. So after the opening of JFlop, there is your number of criteria is here. One for the finite automata, next is your push down automata, next your Turing machine, next diagram. Why? Because it is define your machine diagram. It is divided into 4 parts. I am using the finite automata, so I can open the finite automata window. If you are using push down automata, then you can using push down automata. Okay. Fine. This is my finite automata window box. Here it is a arrow mark to be one state to another state will be defined. Here it will be defined the state creator, just a diagrammatical symbol. Here it is just a transition creator points. Here it will be cross if you will make it wrong, and these are the movement, both the movement for undo option and redo option if you are doing this. So my question is divisible by 2 with all the binary strings. Already I will draw this and then concluded with the 2 state diagram. No more will be using for that. So according to that transition diagram, I have defined the Q0, 0 input, reach at Q0. So I am just clicking here. Just page a wrong window. Just yeah. This is the finite automata, more machine, milli machine, push down machine, Turing machine. I am go for the finite automata. So this is the diagram. I am giving 0, so 0 here, just define here. Another diagram is that Q1, so Q0, 0 input, reach at Q0, Q0, 1 input, Q1, so I am using that symbol Q0 to Q1, so here it is 1, draw the diagram. Next Q1, 0 diagrams, that means Q1 to 0 inputs, I am reached at Q0, so again just this is done it. Next Q1 having 1 input, so it will be having 1 with the Q1, so 1. Now diagram is completed. So now I will be indicate which one is the final state. My final state, initial state is a Q0, so just right click on the state. Here the option final state and initial state both. So I am again click it, this one. This arrow indicate mark will be initial state, double circle will be indicate the final state. This is the indication of the roots. So now my diagram is complete. Now I am going for the test state. So move to the input with the step by step diagrammically you can using. Suppose I am giving here single 0. I am taking only single 0. Just I am taking. So what is my output? This is 0. 0 is divisible by 2. That should be 0 remainder always. So it will be the final state. It is the movement Q0, 0 input state, that will be indicate to be transition stress. Again I am changes. If you are going for the multiple cases, multiple round. So I am getting here 0. Next will be 1, next will be 0, 1, 0, next will be maybe 0 and I am taking also, why I am collecting. Next will be 0, double 1, next will be 1, 0, 0, 0, maybe next will be, just I am write down whatever my string, I did not know, I am just giving it this one, long number. That means suppose my question is that 1042 is divisible by 2, it will be take more time, but in a programmable concept this is easily very done, and you are just calculate the binary number, then you will be done it. So in that process you can just write it, and here it is, run the input, clear it. 0 is divisible by 2, defined as accepted. Here 1 is 1 cannot be divisible by 2, so it will be rejected by the machine structure. 0, 1, 0 is accepted, that's why it will be accepted, because 2 is the 0, 1, 0. So next is that 0, 1, that means binary number is 0, 1 and your integer number is 1, so it will be rejected. Here it is 0, double 1, that is 3, it cannot be divisible, that should be rejected. 100, it is 4, that should be divisible by 2, so it will be accepted. And last string that 10, 10, 10, 10, whatever the string number, I didn't know, you can get it that integer number, but according to machine structure it is accepted. If you want to more clarify that, so you can go this view trace mark. This is the view trace mark, because I am clicking on that particular part, it is the trace option where the movement will be used. First Q0, 1 input, read at Q1, next is 0, so Q1 is having that 0 input, reach at Q0. Now my Q0 is 1 input, reach at Q1, again Q1 is 0. This way it will be defined each and point at last, and just write down that. Fine. Now here it will be check Q0, last input is 0, so it will be reached at Q0, so it is accepted. This is the trace diagram, and clarify that this string is accepted, but in our program I am just giving the input point and it will be so accepted and rejected, that I am showing before window, but in that J flag